In this video, I want to explore still solving some linear system word problems, but this time looking at a few more challenging ones. In the first problem, we're told that we have a plane that travels 1,920 miles to Casablanca and back. So we're imagining that the trip there took 1,920 miles, and then the trip back took 1,920 miles. The trip there was with the wind, and it took 12 hours, and then the trip back was into the wind. The trip back took 15 hours. So if we think about this, this makes sense that flying to a location with the wind at your back, you're going to be moving faster since the wind is helping you. And meanwhile, the trip back is going to take longer since you're going into the wind and the wind is slowing you down. So our task here is to find both the speed of the plane in still air and the speed of the wind. So in order to do this, first we want to identify our two variables, x and y. And I think it's just logical. The two things we're asked to find first, which I can call x, is the speed of the plane. So x is our speed of our plane. And then, of course, the second thing we're asked to find, which I can call our y value, is simply our speed of the wind. So now that we have our two variables identified, the trick is identifying how these variables work together. So first, let's just consider some very basic ideas here. We're talking about a trip that, on the way over, took 12 hours and somehow combined to 1,920 miles. So just to kind of get in the thought of how this works, if, let's say, we were traveling 5 miles per hour, so if I had 5 miles per hour, and if we were traveling for 12 hours, it only makes sense that I would do 12 miles per hour times the 12 hours to find out that in total we had just traveled a total of 60 miles. So in other words, if I can figure out the speed, well, the speed is going to be multiplied by however long we're traveling to figure out the total distance. Keeping this in mind, what we want to do is look back at our problem and think, well, okay, first of all, do I know the speed of the plane? And the answer is no. But do I know how long we're traveling? Well, yeah. We're doing 12 hours of both wind and plane. So first, I can say that 12 times x, this is another way of saying that there's the speed of the plane, x, which we don't know, but it's happening for 12 consecutive hours. So I have to multiply it by 12. In addition, I have the speed of the wind, which is also happening for 12 straight hours on this flight. And these two values somehow combined and give us this value of 1,920 miles on the flight over. So again, just to kind of emphasize, we start with the path of the plane. The plane is traveling some unknown speed x. Because we're traveling for 12 hours, the distance covered will be 12 times x, but then at the same time, the wind is blowing with the plane on the way over, so I'm adding on 12 hours times the speed of the wind, y, and together these things must add up to 1,920 miles. So similarly, on the way back, the trip now took 15 hours. Well, that means I'm still doing 15 times x, or in other words, the plane is still traveling for 15 hours, but on the way back, the wind is blowing against the plane. So that's where I'm now going to put a subtraction sign in. And now I'm actually going to take away 15y since the wind is now acting against the plane at its speed for 15 hours straight. And since the return trip was the exact same length as the trip there, I can simply say, well, we're going to be traveling up to 1,920 miles. Now at this point, we have our two systems of linear equations. And again, just to emphasize, the first one, 12x plus 12y, represents the plane and the wind working together for a total of 12 hours to get that 1,920 miles, where the 15x minus 15y represents the plane and the wind working against each other, and now it took longer, a total of 15 hours, before we can get to the 1,920 mile total. So now I simply have to solve this system, and my recommendation is to somehow either make the 15 and the 12 into a common value. So what I'm going to do, I'm going to recognize that 15 and 12 can both be made into 60. So I'm going to multiply this first equation here times 5, and I'm going to multiply the second equation times 4. And by doing this multiplication, my goal was that I was somehow going to be able to add these two equations and solve by elimination. So I'm going to multiply the first one. Multiplying by 5, I end up with 60x minus 60y equals to 1,920 times 5, which comes out to be 9,600. And then multiplying the second equation by 4, I get again 60x minus 60y. And I noticed that first equation should have been plus, that was my bad. Equal to 1920 times 4, which is 7,680. So again, I noticed in the first equation that the two equations are in fact being added, or the two values, 60 and 60, are being added, where in the second one they're being subtracted. But now I'm all set to add these two equations together, and the y's should disappear. So if I rewrite the equations, and now I'm going to add them together, I found that the 60x and the 60x add to 120x. The 60y and the negative 60y simply add to 0, and the 9,600 and the 7,680 add to 17,280. So in other words, I have 120x equal to 17,280, and if I divide by that 120, we end up getting a nice number, which is that x equals 144. So going back to our original statement then, that x represents the speed of the plane, right? So x is equal to 144 miles per hour. And I can write off to the side here that this is our speed of the plane. Because we always want to identify what these values mean. So this whole value here, 144 miles per hour, must be our speed of the plane. At this point, I have to use our x value to find our y value. So I'm going to plug that 144 back into either equation. The first one looks fine to me. So I'm going to plug in 12 times our x value, 144, plus 12y equals 1,920. And then if I do 12 times 144, that ends up being 1,728. So if I subtract that to the other side, I essentially end up with 12y equal to 192. So now if I simply divide by 12, it looks like we get that y is equal to 16. And again, we don't want to lose track of what the y is. The y is our speed of the wind. So if I go back up to the original here, I can fill in these values. We found that the speed of the plane was 144 miles per hour, and that the speed of the wind came in a little bit under that. So first, our speed of the plane, x, I'll write it underneath, was 144 miles per hour, and our speed of the wind ended up being 16 miles per hour. So now try a similar problem. We have a boat traveling 161 miles downstream and back. So again, the trip there took 161 miles, the trip back took 161 miles. The trip downstream took 7 hours, and the trip back took 23 hours. We want to find the speed of the boat in still water and the speed of the current. So again, let's identify our two variables. Let's call x our speed of the boat. So there's our x, the speed of the boat. And meanwhile, y is our speed of, and since we're talking about boats this time, this will be the speed of the current. So we notice a similar situation this time. The trip both downstream and upstream both are 161 miles. Let's start with the trip downstream. It took a total of 7 hours. So we can write this as first, well, the speed of the boat x was being multiplied by 7 because we're traveling whatever the speed of the boat is for 7 miles per hour. And since we're going downstream, I'm going to add the 7y because that must have meant that the speed of the current y was helping, or in other words, adding to the speed of the boat. And somehow these totaled the 161-mile trip. The trip back, however, took 23 miles. So first, or 23 hours. So first, the boat was traveling at speed for 23 miles, and the reason it took so much longer on the way upstream was because this time the speed of the current was working against it. So much so that it actually took 23 hours before we ended up equaling 161 miles total. So again, just to recap, 7x plus 7y shows that going downstream, the speed of the boat x and the current of the water y were working together, in other words, being added together to get the 161. Whereas the 23x minus 23y represents that now going upstream, the boat and the current are working against each other, so it took longer, 23 total hours, before the boat was able to basically overcome the current and travel 161 miles per hour. So now essentially we need to make this equation solvable. What I would recommend, since 7 and 23 are both prime, I'm going to multiply each equation by each other. So in other words, I'm going to multiply this first equation by 23, and I'm going to multiply the second equation by 7. And this always works, no matter how ugly the numbers get. If I multiply the equations by the numbers, the opposite number that I want to try to add and combine it to, I'll end up getting the same number. So let's go ahead and do that. If I first do the 23 times those 7s, I end up with 161x plus 161y equal to, and if I do 161 times 23, it looks like 3,703. So there's our first equation multiplied by the 23. Now the second equation, because I'm multiplying 7 and 23 again, I'm again going to get 161x, but this time I have a minus 161y, because again this represents the working upstream, so the current's working against the boat. And if I multiply 7 times the 161, this time I get 1,127. So at this point, we're all set to add these two equations together. So if we go ahead and rewrite these, or in other words, if I simply take these two equations and add them together, so plus here, and then draw the line, I notice that I get 161 plus 161, which looks to me like 322x. The two y terms, since one is positive and one is negative, add to 0, which is just what we wanted. And now if I add these two terms, 3,703 and 1,127, we end up with 4,830. So now if we just solve this equation, all I have to do is divide by the 322, and lucky for us it comes out to a nice number. Essentially comes out to the number 15. And we don't want to lose track of what that 15 means. That 15 is our speed of the boat in terms of miles per hour. But we're not done yet. Before we can finish this up, I need to plug that 15 back in to find y. So let's go ahead and do that. If I plug in the 7x, instead of the x, I'm going to write the 15 plus the 7y. Those have to total the 161. I can multiply those together, so 7 times 15, I essentially have 105 plus 7y equals 161. So I can subtract the 105, and I'm getting 56. So 7y equals 56. And dividing by the 7, we essentially find that y is equal to 8. So putting these two answers in context, if I come back up here, we just found that the speed of the boat x was 15, or in other words, 15 miles per hour. And meanwhile, the speed of the current was 8 miles per hour. And these answers make sense. If the speed of the current was over half the speed of the boat, it makes sense that going upstream would take considerably longer than going downstream. That accounts for the difference between the 7 hours and the 23 hours. So now a slightly different type of problem. We're going to go back to digits, which is where we started on solving systems, but this one's a little bit trickier. I'm still asked to find a given number, and the number is made up of two digits, and here's the clues they give us. They say the sum of the digits of a certain two-digit number is 14. So how about we just simply start out very simply by saying that x is digit number 1 and that y is digit 2. Now the first clue they give us is very simple. It says the sum of the digits of a certain two-digit number is 14. So in other words, they're basically saying that if I take x and add y, I'm going to get 14. And we've written equations like this quite a bit in the past. This is not too hard to get started on. The second one, however, though, is a little bit trickier. It says reversing its digits increases the number by 36. Find the number. So first, let's just talk about what it means by reversing its digits, just as an example over here. Let's say I had the number 24. Well, if I reverse the digits, or in other words, if I swap the 2 and the 4, this becomes 42. And we see that the difference, or in other words, the increase of going from 24 to 42, is that the number has actually gone up by 18. So there's just kind of a simple example. What they're asking us to find here is that when I switch the digits of the number, they actually increase up to 36. So the question is, well, how do we do that? Well, here's what we're going to essentially focus on when I talk about a number. When I talk about the digits, 24, if we go back to just the number 24, is really the sum of two different numbers. It's the sum of 20, the tens place, that represents 2, and the number 4. Now, really what this is, the number 20, if I actually break it down, is really the number 2 that we see sitting here in the tens place, really implied being multiplied by 10 because it's sitting in the tens place. So if I want to show that a number is sitting in the tens place, all I really need to do is multiply it by the number 10, and meanwhile I can simply add on the second number. So to see this in action, if I flip the number and get 42, well, we recognize that 42 really is just the sum of 40 and 2, and that really all 40 is the number 4, the number we see sitting in the tens place, times 10, then being added to 2. So if I keep this whole pattern going, if we recognize what this means, essentially, let's assume that x starts in the tens place. That means the value of 10 is really 10x. In other words, that value of x is being multiplied by 10. So really the first number starts out as being 10x plus y. Here's our first number. What they're then saying, though, is that if I switch the digits, the number actually becomes and increases and becomes a number that is 36 larger. So if I take away the next number, in other words, if I flip it, now y is in the tens place, and x is now the number not being multiplied. And since the second number should be 36 larger, I should end up with a negative 36 as a result. So again, let's go through this because this can be a little tricky. If I want to start with x in the tens place, which I do, I'm going to start by indicating right here that x is really being multiplied by 10. That's what indicates it's in the tens place. Meanwhile, the y is not. Meanwhile, though, if I then want to reverse the digits, in the second one, it now means that y is in the tens place. Right? So now it's being multiplied by 10. And x is now not in the tens place, but is rather in the ones place, so it is not being multiplied by 10. So that's why I've switched these. Now to relate these two, the second one is supposedly 36 larger. So if I subtract the larger one away, I should see then that I end up with a negative 36. In other words, I took away a number that's 36 larger, so I should end up with a negative 36, and that's what we see here. Now luckily, this is the hard part done. All I actually have to do now is simply combine these terms, get a simple equation, and then solve. So let's go ahead and do that. I'm going to erase all this stuff off to the side here, so we have a little bit more room now that we have our two equations. And let's go ahead and simplify. First of all, I'm going to just keep that first equation the same. X plus y equals 14. No reason to change that. Now here I notice if I subtract, or in other words, if I distribute this negative here, I'm going to end up with a negative 10y and a negative x. So when I combine these, really we're going to end up with 10x plus y minus 10y as I distribute, and also minus x equal to a negative 36. So again, really all I'm doing there is just distributing that negative to both terms. So now I'm going to rewrite x plus y equals 14 one more time. Now I can combine our like terms. So 10x and a negative x becomes 9x. Y and a negative 10y becomes minus 9y. And that's still equal to a negative 36. And there essentially is the equation we want to solve. So I'm going to rewrite that second equation up here. And now I essentially just need to solve this. So I notice that I have a y and a negative 9y. All I really need to do then is multiply this first equation by 9, and I can keep the second one the same. So if I go ahead and do that, if I multiply that first equation by 9, I'm going to end up with 9x plus 9y equal to whatever 9 times 14 is. And if I do that out, I end up with 126. Meanwhile, I'm keeping that second equation the same. 9x minus 9y equals a negative 36. So now if I add these two equations together, the 9x and the 9x becomes 18x. The y's cancel. And 126 and negative 36 simply adds to 90. So now if I do 90 divided by 18, we get the nice answer that x equals 5. So in other words, they're saying that the first digit must be 5. Now let's keep this in mind as we keep moving forward. I still need to find that y digit, so I'm going to plug back in. Now luckily we have a pretty easy equation to solve. I'm going to plug right back into x plus y equals 14. So if x is 5, in other words I'm saying 5 plus y equals 14, then that means that y must equal 9. Now let's keep in mind what this means. That means I have a two-digit number. If I go back up here, the first digit is a 5 and the second digit is a 9. Well, let's see. If I add 5 and 9, do I get 14? I sure do. But here's the more important test. Here's the check. If 59 is in fact my answer, I should be able to swap the digits, and I should have just increased the number by 36, and that's true. Right? 59 going up to the number 95, that is an increase of exactly plus 36. So when I swap the digits 5 and 9, not only do they add to 14 in both cases, but now I can clearly see that they've increased by 36. So now that we've got one of those under our belt, let's try another one. It says, when you reverse the digits in a certain two-digit number, you increase its value by 9. What is the number if the sum of the digits is 7? So let's start off with the same thing. I have two digits. I'm going to call x digit 1, and I'm going to call y digit 2. So we'll start with the easy one. It says, what is the number if the sum of its digits is 7? That's definitely the easier equation, so I'm going to start there. I'm going to say x plus y is equal to 7, right? The sum of the digits is 7. That's good. Then it's saying when you reverse the digits, you increase its value by 9. So again, let's start with the first number. If I assume we start with x in the tens place, that means I have 10x, and that means y is not in the tens place, so I'm going to add y. However, if I take away the second number, so if I now switch it, and y is in the tens place, so it's now being multiplied by 10, x is in the ones place, so it's now being multiplied by 1, they said that the second number is larger by 9. So subtracting, I must end up getting negative 9. Right? I'm subtracting away a larger number, a number larger by 9, so I'm going to end up with a negative 9. So I need to clean up these equations. So first I can keep x plus y equals 7. I'm going to distribute that negative first, so 10x plus y equals, minus 10y minus x is equal to a negative 9. And now I'm just going to simplify that equation, so I still have x plus y equals 7, but now that second equation combines to 9x minus 9y equals simply a negative 9. You might notice there's a pattern here. If I'm swapping the digits, I'm always going to end up with this 9x minus 9y equation. The only thing that's changing is what I'm setting it equal to. You'll notice that this time it's actually a negative 9 compared to what we had last time. So I'm going to rewrite this equation up here so I have more room to finish solving. Again, if I want to finish solving this equation, I simply need to multiply the first equation by 9. That way the y's will cancel away. So as I rewrite this equation, I end up with 9x plus 9y equals, and if I do that 9 times 7, that looks like 63 to me. Second equation, I'm going to keep the same because I already have that negative 9y that I want. So I can add these two equations together. And it's now equal to a negative 9. So now I'm all set for elimination. I can add these two equations together. And the 9x's combine to 18x. The 9y's cancel. And those add up. And if I do 63 minus 9, I end up with 54. Which is nice because now as I divide by 18, I end up with x equals 3. So there's our first digit. Let's keep that in mind, but I still have to get the second digit by plugging in. So I'm going to take that simpler equation, x plus y equals 7. If I plug in that x is 3, then we can pretty clearly see that y is equal to 4. So in other words, I've been giving a two-digit number. If we go back up here, the first digit I've been told was 3. The second digit I was told is 4, and I'm pretty confident that this is our answer, but let's check. First of all, are the sum of 3 and 4 7? Well, yeah, but here's the better check. If I swap the order of the 3 and the 4, and now I go up to 4 and 3, has it in fact increased by exactly 9? And the answer is yes. So this is correct. So for the rest of homework, I've given you 3 word problems to try, very similar to what we did here. Go ahead and give those a try, and then we'll check back in next class.